Alright, this is the fourth and final part of the lesson, the probability review. Let's start off with number 10, Venn diagram. Triple Venn diagram. Aw, shucks. What's going on? Let's see. If event C is liking comedies, event H is liking horror movies, and event R is liking romantic comedies. Use the three-way Venn diagram below. Answer the following questions. How many total people were sampled? Well, we will simply add up every single number, not just the ones inside the circle, but the two outside the circle. So I'm going to do that off camera, but all I'm doing is adding up all of these numbers, including the 2. Alright, I am getting 119. Now, what does the 2 represent? The 2 represents people that do not like any of these 3 genres. 2 people like neither comedy nor horror nor romance. How many total people like comedies? Well, we're talking about these 4 numbers. Just going to add those up off camera. Well, I could do it now. 50 plus 10, that's 60. Plus 13, that's 73. Plus 5 more, that's 78. What does the 10 represent? Alright, the 10 represents 10 people like all 3 genres. A genre is a type of something. So in this case, we have our 3 genres of movies. E, find the probability that someone would like comedies given that they like romantic comedies. I really don't like the way that we are using the word comedy in 2 different contexts. So I'm going to change this to romantic movies. Because romantic comedies, that sounds like overlap. Anyway, find the probability that someone would like comedies given that they like romantic movies. So once they say given that they like romantic movies, that means that we are given that this is the new universe right here. So only this yellow area exists for the rest of this problem. Okay, you could black out everything else. Maybe I will. One more. Okay, so given that they like romantic movies, so that's this universe right here, we've blacked out everything else because that no longer exists. So given that, find the probability that someone would like comedies. Alright, I left the little C showing to remind you that this circle was the circle of comedies. Okay, and also I guess you need to remember that the comedy circle includes both of these numbers right here. Alright, both the 5 and the 10 are part of the comedy. You know, this was the comedy circle. You know, this over here was the horror circle. But 15 people are feeling the comedy. So 15, you can't see that. 15 out of something. Alright? Now 15 out of what? Not 110, I'll tell you that, because we blacked out most of that old universe. It's 15 out of just these 4 numbers. Okay, because this is our new small universe. So what do I have here? 24, 28, and then that's going to be 33. So in this new smaller given universe, 15 out of the 33 like comedy. And we will reduce this. Both of these are divisible by 5. I'm sorry. Both of these are divisible by 3. So that's going to be 5/11ths. Okay, that's the probability. Notice I'm switching because for problem A and C it said how many people, 119. How many total people, 78. But here for part E, they're switching the word to probability. So I'm doing target over total. I'm doing a fraction, or I could have done a percent. Find the probability that someone would like comedies and horror movies. So we're not given anything, but comedies and horror movies are represented by this part of the diagram, comedies and horror. Okay, so that's 23 people. So as I do my target over total, I'm talking about 23 out of the 119 in the survey. Okay, I'm not shrinking the universe. It didn't say given anything, so probability is someone would like comedies and horror. Oh, well, that's 23 out of the 119. Now, find the probability that someone would like comedies but not horror movies. Let's see. Comedies but not horror. So once we're talking comedies, we're talking about this. You know, if we had just said comedies, we would have been talking about these numbers because these are all the comedies. All right, but then they had to go and say comedies but not horror movies. So if we sort of take out the horror movies, we're taking out the 13 and the 10 because those are both horror movies. So that leaves these numbers to be comedies but not horror movies. Okay, so that's 55 people. 55 out of 119. Okay, this will not reduce. 119 is a prime number. Okay, so that's it for the triple Venn diagram. I can return this to its previous. Okay, moving on to number 11. Use a regular 52 card deck to find the following probabilities. You are drawing 2 cards without replacement. Okay, so we're not putting any cards back. What is the probability of drawing an ace and a 2? Okay, so if I want to find the probability of drawing an ace and a 2, then we're going to be using the AND formula. So we're going to find the probability of drawing an ace. Let's see. The probability of drawing an ace and a 2 is going to equal the probability of drawing an ace times the probability of drawing a 2. Now, I'm going to say probability of drawing a 2 given that we definitely drew an ace the first time. All right, because that's what the story says. All right, well, let's start with the probability of drawing an ace. How many aces are there in the deck? Well, there's 1 ace in each suit. All right, so there are 4 aces in the deck out of a total of 52 cards. Okay, so 4 out of 52. All right, that's a probability of 1/13. Okay, so I'll just put it over here. So I've got a probability of 1/13. Now let's find the probability of of drawing the 2? Well, let's see. Target over total. How many 2's are there? Well, there are, once again, there are 4 2's. All right, now we drew an ace before, but we didn't take out any of the 2's, so there are still 4 2's. Okay, so 4 2's out of a total of how many cards, though? Because we're not replacing, we don't have 52 cards anymore. When we go to reach to draw the 2, it's 4 out of 51. All right, because we already drew the ace, so that leaves 51 cards. Okay, so let's go ahead and multiply this out. So 1/13 times 4 over 51. Okay, so that's 4 over 663. All right, I'm curious what the percentage is on that. Okay, that's 0.006. So even if I move this decimal place the 2 times like you do, okay, that's still less than 1%. That's 0.6%. All right, very low odds if that's what you were hoping to draw. Okay, anyway, I'm just going to leave it like that, though. All right, you were drawing 2 cards with replacement, so we're putting cards back now. What's the probability of drawing an ace and 2? So same question as before, only this time with replacement. So same thing as before. All right, the probability of drawing an ace and a 2, that's going to be the probability of drawing an ace times the probability of drawing a 2. This time I don't need to say given that we drew an ace, because we're putting the ace back, so we're starting fresh, so I can just calculate separately. So again, the probability of drawing an ace is 4 out of 52, which reduced down to 1/13. Now the probability of drawing a 2 will also be 4 out of 52. Okay, because we put the card back, so we have the whole 52. So again, 4 out of 52 is 1/13 again. So 1/13 times 1/13, you multiply straight across, so that's 1 out of 169. Okay, now draw a Venn diagram to represent the events black cards and face cards. Okay, so I guess we'll have to do that off to the side here. Black cards and face cards. Alright, so I'm getting my Venn diagram ready. We need black cards and face cards. Okay, so I'm going to need a smaller pen. I'll let this circle represent black cards, and this circle will represent the face cards. So obviously in here we will have black face cards. So how many of those are there? So these are the face cards, okay, and there are 6 of them that are black. All right, so there's 6 black face cards. Okay, so let me change colors here. So there are 6 cards that are black face cards. Now, how many face cards were there total? Well, there's 6 black ones and there's 6 red ones. Okay, so there's a total of 12. So I'll put 6 out here to represent the other 6, the 6 red face cards. Now, okay, how many black cards are there total? Well, in the deck, there's a total of 52 cards. So there are 13 clubs, 13 spades. That's 26, all right? It's half of the 52. All right, so there are 26 black cards total. Now, there's 26 black cards total, but 6 of them are already right here because of the face cards. So that leaves 20 more out here. So there are 20 black cards that are not face cards, plus the 6 that are. Okay, so we've got black cards and we've got face cards. We still need the number out here for cards that are not black or face cards. Okay, they're neither, and that's what goes out here. Okay, I'm going to put those in green. Let's see. There are 26 black cards, so forget about those. All right, those we had a circle for those, and so that leaves 26 red cards. But we need red cards that are not face cards. All right, because face cards is one of the circles. So I need non-face cards. Okay, so there were 26 red cards. Subtracting the 6 face cards, that leaves 20 non-black, non-face cards. All right, so 20 of those. So I'm going to put the 20 out here. Okay, so if I added all of these numbers together, I should get 52. So let's see, 20 plus 20 is 40. 6 plus 6 is 12. 40 plus 12 is 52. So it makes sense. Alright, so that's my Venn diagram there. Now, for part D, draw a Venn diagram to represent the events kings and queens. Alright, these two events are mutually exclusive, alright, because you can't be a king and a queen at the same time. So I'll let this circle represent kings, and I'll let this circle represent queens. Alright, of course, there are 4 kings, and there are 4 queens. Okay, so that's 8 cards out of the 52. So how many does that leave to be outside of both of these circles? Alright, so 52 minus the 8 that we've already got, that leaves 44 cards out in the cold. Alright, so there's your Venn diagram. Mutually exclusive, kings and queens, not overlapping. Okay, what's this one? Draw a Venn diagram to represent the event's prime number cards, 2 through 10, and red cards. By the way, the number 2 is prime. So prime numbers are numbers that can only be written, only be factored as 1 and themselves. So prime numbers are, prime numbers that are less than 10 are 2, 3, 5, and 7. Alright, 9 is not a prime number. So these are all the prime numbers between 2 and 10. Okay, so I want prime numbers, prime number cards 2 through 10, and red cards. Okay, So obviously there's overlap here, so I'm going to go back to an overlapping Venn diagram. Alright, prime number cards and red cards. So I'm going to let P represent prime number cards in this circle right here, and I'm going to let R represent the red cards, which will be in this circle here. Okay, so let's talk about the overlap between prime number cards and red cards. So remember, 2, 3, 5, and 7. Those are the, in this zone, those are the prime number cards, 2, 3, 5, and 7. Okay, so looking back at the picture, okay, we have 2, 3, 5, and 7. There's 4 different ones, and there's 4 of each of those. So that's 4 times 4, so that's 16. So there's 16 prime number cards. Okay, so I'm just going to temporarily remind ourselves that there are 16 of these. Okay, now how many of those are red out of the 16? Okay, well, half. Alright, so if we look at the 2s, I got half black and half red. Well, half black, half red. When I look at the 3s, half black, half red, and so on. Okay, so half of these prime number cards are going to be red. So that means 8 of them are going to be prime and red. And meanwhile, 8 of them, I missed. 8 of them will be prime and not red. In other words, black. Okay, now let's talk about the red cards. So the red cards are half the deck. Okay, so we know that the red cards, there are 26 of those. 8 of them have already been accounted for right here. So 26 minus the 8, that's going to be, what, 18. Yeah, 26 minus 8 is 18. In other words, if I add these up, if I add up 18 and 8, because that's all the red put together, I'm going to get the 26. Okay, so how many cards does that leave out of the 52? Well, we have 8 plus 8 plus 18. That's 16 and 18. Okay, that's 34 cards so far. So how many does that leave? That leaves 18 other cards. Okay, so I'm going to put that out in the cold. Alright, so there are 18 cards that are neither red nor prime. So if you add all these up, you should get 52. Okay, so that's our Venn diagram. Alright, 2 more questions left. A new donut shop in town is trying to figure out what items will sell the most. Throughout their research of local donut shops, they have found 63% of customers purchase a donut, 80% purchase coffee, and 88% purchase a coffee or a donut. They want to know what percent of people purchased a coffee and a donut. Okay, so it's hard to just know that you're supposed to use the formula. Okay, but if as you read that long paragraph, listen to the things that show up in this paragraph. what do they say again? Alright, so we've got, let's label this stuff as we go along. Okay, 63% of customers purchase a donut. So let's call that event D is my donut people. Alright, so D for donut. You know what, I need my bigger pen back. Fact. Go big or go home. So so donut, that's our 63%. 80% of people purchase coffee. All right, so we'll call that event C is coffee. That's 88%. Wait, I lied. That's 80% is the C. All right, 80% of people are coffee. So, you know what? I feel like let's make a list. So they gave us the probability of D. Okay, 63% donut eaters. Okay, and then they gave us the probability. They get 80% of people purchase coffee. All right, so they gave us the probability of C. That's 80%. Okay, now here's where it gets interesting. They said, all right, 88% of people purchase coffee or a donut. Okay, that's C or D. So they're telling us the probability of C or D is 88%. Okay, now they want to know what percent of people purchase coffee and a donut. Okay, coffee and donut, question mark. That's what we're trying to find. The probability of C and D. Okay, so look at all these things we have. We have D, C, C or D, C and D. So when you think about our formulas, where we have the individual probabilities, and then we have A or B, and we have A and B. These are the things that are all involved in this story. So that's a signal to us that we're going to need to use this formula. Obviously, instead of A's and B's, we're using C's and D's, but same difference. All right, so remember, it's going to start off event, A or B, or but we're going to say it like this: probability of C or D is equal to the individual probabilities minus the overlap. Okay, I feel like I'm going to have to zoom in. Alright, so just copying that formula down, probability of C or D is going to equal the individual probability, so probability of C plus the probability of D minus the overlap, so probability of C and D. Okay, this is the formula. Now let's see how many of these things we know. All right, probability of D, 63%. Okay, 63%. All right, probability of C, 80%. Okay, the probability of C or D, 88%. Okay, so the only thing we don't know is the probability of C and D. Okay, so let's go ahead and add these together. 80 plus 63, of course, That's 143. So 88% is equal to 143% minus the probability of C and D, which is what we're supposed to find. Okay, subtracting 143% from both sides. All right, 88 minus 143. All right, that's negative 55%. And that's equal to negative probability of C and D. Now we want just plain old the probability of C and D. So technically we're dividing both sides by -1, but essentially we're changing both of the signs. So probability of C and D is 55%. So 55% of the people are going to want coffee and a donut. Okay, so let's just write that down, and I'm going to have to erase all this for the next problem. So 55%. Okay, I'm going to say goodbye to all this beautiful work because I need space for number 13. Last problem. For two events B and C, it is known that the probability of C given B is 0.61, and the probability of C and B is 0.48. Find the probability of B. Well, they're just giving us all these pure numbers and asking us to find something, so it sounds like a formula to me. Now, what formula involves, event and event, and event given event? Well, let's see. It's going to be a version of this blue formula right here. But this formula was written holding in mind two independent events. But we know that if it's going to be dependent events, then we have to tweak this formula a little bit, and it becomes, all right, the probability of A and B is the probability of A times the probability of B given A. Okay, that's what the formula becomes when it's dependent, when there's something that's given. Like when you don't replace the cards when you're drawing. Or here's another version of the formula that has it right in there. Okay, but I think I'm going to stick with this version of the formula and see what I get. Alright, so basically if I write down the AND version of the formula for event B and C, I could say that the probability of event B and C, and I see they're using the symbol, so will I. So the probability of event B and C is going to equal the product. Alright, so it's going to be the probability of event B times the well, that's not a probability, times the probability of event C given B. Alright, I'm going to use this version of the formula since I see that the given is right there. Alright, so let's substitute in everything we know. So probability of C given B, that's given as 0.61. So I'm going to put my 0.61 right here. Let's see, probability of C and B is 0.48. Okay, so that's going to be this right here, so 0.48. So the only thing that's missing is probability of B. That's the thing that we're supposed to find. Okay? So if I want to get the probability of B by itself, I'm going to have to divide to get rid of this 0.61. So I'm going to divide both sides by 0.61. That way these will cancel each other out, and I'll be left with the probability of B. So 0.48 divided by 0.61. Okay, I'm going to have to round. Remember to keep 4 decimal places when you do a decimal for probability. So 0.7869. Got to round up. 7869. Alright, must use 4 decimal places. So that is the probability of B. So that's the answer. Alright, of course you could write it as 78.69%, and that would be just as good. Alright guys, that is finally it for the 4th and final part of this review. I hope it was helpful. Please make sure that you can do each and every problem by yourself without copying off of the video, because I won't be there sitting next to you telling you how to do the problems when you take a test. Good luck, guys. See you on the next unit.